Today we are talking about finding the least common multiple of two or more numbers. This is essentially the opposite of the greatest common factor. So when we talk about multiples, think about the word multiply. If you're finding multiples of 3, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So 3, 6, 9, 12, 15, those would be multiples of 3. So multiples that are shared by two or more numbers, we call those common multiples. And then when you find the least of those common multiples, the smallest one, that's our LCM. So LCM is the abbreviation we use for least common multiple. So let's go ahead and look at two different methods. So very similar to what we did with GCF, our first method is just listing the multiples. So if we're, for example, if we're going to find the LCM of 4 and 6, the first thing we're going to do, step 1 here, is to list the multiples of each number. So I'm going to make a list of the multiples. Now, with multiples, they can keep going and going and going. There's not necessarily an endpoint like there is with factors. So with multiples, you may want to just do the first 4 or 5 multiples, and then if you still don't have one in common, keep going. So here's what I mean by that. For multiples of 4, I'm going to start with 4. And then essentially, I'm using repeated addition. So I'm going to add 4 more, and then add 4 more, or I can just think about my math facts and do 4 times 1, then 4 times 2, 4 times 3, 4 times 4. Again, you can just use repeated addition as well and just add 4 every time. So I'm just going to do the first 4 multiples, and then I'm going to move on to 6. So I'm going to start with 6 and then add 6 each time. So those would be my multiples of 4 and 6. So when I say they keep going and going, we could just keep adding 4 and just keep adding 6, and it wouldn't stop. So find yourself a stopping point, and then you can reevaluate. So step 2 then is going to be to just identify the smallest multiple they share. So this would be that common multiple. So instead of looking for the biggest one like we did with GCF, we want the smallest one. So we want the first number you come across that they have in common. So 4, 6, 8, oh, I can see they both have a 12. And that's the first number I came across that they share. So that means the LCM of 4 and 6 is 12. Please remember, if you have any questions, pause, raise your hand and ask me, send me an email, comment here, or just write it over here in the margins to ask me in class. All right, we're going to look at a second method of finding LCM, which is using prime factorization. So much like with greatest common factor, we would use this method when we have really big numbers, and we're going to be listing a lot of multiples. So we're going to use 16 and 20 for this method. And our first step, of course, is to make a factor tree for each number. Since we're working with prime factorization, we need to make a factor tree. So I'm going to go ahead and make a factor tree for 16 and a factor tree for 20. Remember, with your factor trees, you can start with any factor pair. So I could use 2 and 8, I could use 4 and 4. and until I get to the prime factors. I'm going to do the same thing for 20. We could use 2 and 10. We could use 4 and 5. Does not matter. We will still get the same prime factors. Okay, so we made our factor trees. Now we're going to write the prime factorization of each number. So that's where we write it as a product. So that means I'm going to take 16 and I'm going to write 2 times 2 times 2 times 2. And then for 20, we have 2 times 2 times 5. Now here is where it gets a little bit different than what we did in GCF. So step 3, this is where it gets different. This is very important. Step 3, we're going to circle each different factor. Where it appears the greater number of times. So what that means in this case is we are going to use every factor that we see listed, not every time we see it listed, but that means we need to have a 2 and a 5 somewhere in what we're multiplying. So when I look at the 2's, the 2 appears most often up here by 16. So the 2's appear most often here. I have 4 2's and then 2 2's. So I want to use these 4. I want them where they appear the greater number of times. And then the 5 only appears once down here, so I'm going to use 1 5. So these 2's show up the greater number of times. I also need to use this 5. We do not circle the 2's again since we've already circled them. So again, I want to use each different factor. So I'm using the 2's and the 5 where it appears the greater number of times. So if I look at the 2's, they show up the most here, so I'm going to use 4 2's. 5 only shows up once, so I'm going to use 1 5. And what I'm going to do with those is find the product of the circled factors. So that means I would take 2 times 2 times 2 times 2 times the 5. That would get me to 80. I can do a little mental math here. I started with the 5 times 2, knowing I would get 10, then did 10 times 2, 20 times 2, 40 times 2. So that means the LCM of 16 and 20 is 80. So two different methods here that we can use. Both work just fine. I know there are more steps with prime factorization, but again, you would use this when you have a really big number. So if we go ahead and turn the page, this talks about another option or another opportunity and when we would want to use prime factorization. So finding the LCM of three numbers. So if I have 4, 15, and 28, if I tried to list these multiples, so let's say we go ahead and list our multiples of 4. And then we start listing some multiples of 15. But then we move on to 28. Well, we haven't come across anything that they share yet, and it may take us a while. So from here, this is where we may decide that we want to use prime factorization. So I'm going to go ahead and circle, or I'm going to go ahead and create factor trees for all of these. This method is going to take us a long time with these three numbers. In some cases it would work. In this case it would take too long. So I'm going to go create a factor tree for each of my numbers. So here's my factor trees. Okay, then we have to list the products, the prime factorization of each. So I have 4, which is 2 times 2. Then 15, we got 3 times 5. And then 28, we had 2 times 2 times 7. All right, so now our next step is going to be to figure out where does each factor show up the most. So the smallest factor I have is 2, and I can see it shows up twice here and twice here, but we only need to use it twice. It shows up the greatest number of times in one spot twice. So 2 and 2. Then I don't need to use these 2's. 3 shows up once, 5 shows up once, and 7 shows up once. So now I'm going to multiply all of those numbers. So I'm going to rearrange this for a little bit of mental math strategies here. So I can see that 5 times 2, I know that's going to get me 10. Okay. And then I know that 2 times 3 is going to give me 6. So this makes my mental math a little bit easier. I can do 6 times 10 is 60 times 7 is 420. So the LCM of 4, 15, and 8 is 420. We can see that prime factorization is a better option here because it would take us a really long time to list multiples all the way up to 420 with this method.